GSK recently updated their solvent guide. We have updated our scoring methodology, refreshed the over 3,700 data points feeding into the guide, and increased the number of solvents scored from 110 to 154. It's not practical to show the scoring of 154 solvents at any one time, so while our internal website allows interrogation of the full set of solvents and ranking via various scores or properties, we have also prepared some simpler views. This view, for example, covers 55 solvents commonly used or recommended in our drug discovery laboratories. It is rotated 90 degrees from our previously published MedChem solvent guide to make it visually distinct. It emphasises that the solvents are on a spectrum of greenness, with the relative positioning within each colour band representing the overall greenness score. You can see that, as might be expected, some classes of solvent, such as alcohols and esters, are intrinsically greener than others, such as dipolar aprotics or chlorinated solvents. But you can also see variation within each class. Solvents with multiple data gaps, where assumptions have had to be made in their assessment, are shown in italics, reflecting a greater degree of uncertainty in their relative positioning. This is a very simplistic view. It's meant to serve as a quick visual reminder, and the reverse of the guide provides more detailed information. The reverse of the guide shows the solvents, grouped by solvent class, and ordered within each solvent class from greenest to least preferred. CAS numbers are provided for ease of ordering, and the overall composite colour score. Solvent boiling points are provided, with high boiling points shaded red, emphasising the potential problems in removing or recycling these solvents, and low boiling points shaded red, emphasising the potential volatility concerns of these solvents. Waste scores are then given for incineration, recycling, biotreatment and VOC emissions. Environment scores are given for aquatic and air impact. Human health scores are health hazard and exposure potential, and safety score are for flammability and explosion risk, and reactivity and stability. In a change to our previous scoring rubric, life cycle analysis no longer feeds into our overall score. This is in no way a reflection of life cycle data being taken less seriously. This is still regarded as extremely important, and hence is why the information is still displayed here on handouts, and internally on our more detailed solvent database. We have simply removed it from our composite score because the data was lacking for so many new solvents that we had to make assumptions, and in many cases interpolations based on interpolations, and this was felt to be insufficiently rigorous. This view covers 55 reasonably common solvents. We also pulled together a separate view, reflecting just the 54 solvents that we have recently scored. As these were chosen largely based on suggestions in the literature that these might, by various criteria, be greener alternatives, it is not surprising that by our methodology we also see more green solvents on this list. It is worth noting that many of these amber solvents are only amber because our methodology automatically demotes any green solvent with 5 or more data gaps to this classification, as we can't be completely sure on our scoring. This view does not include life cycle analysis, as we do not have this data for any of these solvents. Instead, it highlights how many assumptions have had to be made in the scoring of each solvent. The solvents shown here are generally lesser known, and we are wary of recommending drop-in replacements, partly as true like-for-like replacements rarely exist, and partly as we still need more data on many of these solvents. However, there are a couple of interesting new solvents worth tentatively highlighting here. Dimethyl isosorbide is used as a base for sunscreens, and hence is available in reasonable quantities and has a reasonable safety profile, though of course its potential for skin penetration must be borne in mind. It is sometimes a viable replacement for dipolar aprotic solvents in some coupling reactions. Likewise, cymene can sometimes be a preferable alternative to toluene. Mindful of the fact that for many years chemists have used references such as the JOC paper and magnetic resonance in chemistry paper as key references, we thought there was an opportunity to remind chemists of the sustainability credentials of their solvents when they looked up their NMR shifts. We also saw potential here to remove one of the barriers to using some of the less familiar green solvents. As such, we recently published our internal guide. This is a compilation of previously published data and newly acquired shifts of 70 different solvents in 6 different NMR solvents. The green solvents are shown with 2 leaves, the amber with 1 leaf. Additionally, while this by no means represents a crusade against the small amounts of deuterated chloroform used in spectroscopy, as a secondary consideration, we do shade the NMR solvents themselves from most to least sustainable by our methodology. We should say we're not the only people to have had this idea, and Dow AgroSciences published a similar article in OPRD at the same time as we published this in Green Chemistry.